Hey everybody, welcome back. We are doing section 1.3 in this video for business calculus, and we're going to be dealing with linear equations today. And specifically, linear equations that are of the form y equals mx plus b. And I'd like to point out that the m in this case is the slope, and the b in this case is the y-intercept, meaning that's when x equals 0. And we have a formula for the slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right. This is also referred to as the rise over the run. It's basically a rate. How quickly are things changing? And the rate of change actually in calculus becomes a major thing because, well, you'll see why. It's coming. So let's start our first example here of a linear equation. A town's population has been growing linearly. In 2003, the population was 64,000. This is my B. This is my y-intercept. This is where we're starting. It's called an initial condition. The population has been growing by 1,700 people per year. Here is my M. So my population is going to be 1,700 times x, where x is the number of years after 2003, plus where we started, that's the 64,000. And that is our actual equation. And so it says use the formula to find the population in 2029. So they want to know the population. Now, 2029 is exactly 6 years after 2003. So 1,700 times 3 plus 64,000. Looks like we have about, that's 6 years, not 3 years. What are you doing? Let's fix that. 6 years. There we go. So this is going to be 74,200. That's a 4. And this is people. And where am I getting the 6 from? Well, if we go from 2003 to 2009, that's a difference of 6 years. So that's where my 6 came from, not my 3. All right, let us move on. So just want to make sure we highlight that by 2009, assuming the population remains linear following that model, there will be 74,200 people in that town. A phone company charges for service according to a formula C of n equals 18 plus 0.05 n, meaning the cost, where n is the number of minutes talked to, and C is the monthly charge. So the rate of change in this equation is the slope. That's the number in front of the variable. So that's 0.05. And that's going to be, and the initial value is going to be the 18. And that is in dollars. And this is dollars per month. So pretty easy. Again, this is written a little bit differently than we have. This is actually B plus mx. Again, the m is always the coefficient or the number multiplied times the variable, in this case, n. All right, equation 3, I had to actually go look up in your homework because there were so many blanks here, I wasn't sure what to put. So Terry is skiing down a steep hill. Terry's elevation, E of t, in feet after t seconds is given by E of t equals 4,100 minus 80t. t. So I want to be very clear on how they are wording this. It says, the equation tells us that Terry started at an elevation of, and this is going to be 4,100 feet. And actually, I think the way this is worded is it should be 4,100 here. And then here, the drop down is in feet. And his elevation is decreasing by 80 feet per second. Now, you got to be careful. It might be tempting to put negative 80, but because we say the word decreasing before that, that is the negative for us. So decreasing by 80 is correct. If you say decreasing by negative 80, that means it's actually going up because you end up with a double negative there. So just be really careful in the wording of that one. All right, next up, if f of x is a linear equation and f of negative 3 equals 4 and f of 3 equals negative 4 from the equation. So what we're going to need to do, first of all, is find the slope. And to be clear, this is y sub 2, x sub 2, x sub 1, and y sub 1. So this is going to be negative 4 minus 4 over 3 minus negative 3. Be really careful with the double negatives. I'm getting negative 4/3. And we have something called point slope form. And that is y minus y sub 1 equals m times x minus x sub 1. And then we're going to put the whole thing in a slope intercept. X sub 1 in this case is either the negative 3 or the positive 3. We can pick whichever point we want. And so I'm going to pick the first point. So this is going to be y minus 4 equals negative 4/3 times x minus negative 3. So negative 4/3 times negative negative becomes a negative again, but the 3's reduce out, and I'm just left with the minus 4. And so this gives me y equals, if I add a 4 to both sides, negative 4/3 x. And that's it. Y equals negative 4/3 x. And that is the complete answer there. Y-intercept is 0 in this case, which is cool. To get to our next problem, question 5 is actually on the next page, so you'll need to flip down. Again, the PDF is a little awkward here. So a clothing business finds that there's a linear relationship between the number of shirts N it can sell and the price P it can charge per shirt. In particular, historical data shows that 6,000 shirts can be sold at a price of $41, while 9,000 shirts can be sold at a price of $14. So I want to be clear, what we have here are two ordered pairs. We have 6,000, 41, and we have 9,000, 14. So to find our slope, we're going to need to do 14 minus 41 over 9,000 minus 6,000. And that is going to give us negative 27 over 3,000. And when I divide that out, too many. I'm going to get negative 0.009. Now that's my slope. And I can use either point, and I'm going to use point slope form again. You can see that up there. Y minus y sub 1 equals m times x minus x sub 1. And I'm going to plug that in. I'm going to use the first point here. So this is going to be y minus 41 equals negative 0.009 x minus 6,000. And I'm going to take that number times 6,000. 6,000. So this is going to give me y minus 41 equals negative 0.009x plus 54. So this is going to give me y equals negative 0.009x plus, I did that incorrectly. It should be 54. I see what I did. 54 plus 41. Yes, 95. So my answer is going to be P, not Y, is negative 0.009 x. That should be N, actually, plus 95. So here is my equation. Yep. And number 6 is how to graph a line that is in slope-intercept form. Now, the way this works is, remember, this here, this is the y-intercept, which means this is where this graph crosses the y-axis. Now, the slope, the negative 1/2, means that I'm going to go up 1 and back 2 to get me this point here, or down 1 and over 2 to give me this point here. Either way, you can see all 3 points are on the same straight line. Let's see if I can draw a straight line. Let's make it darker. And there we have our line. Now, you don't need to go up and to the left and down to the right. You can just do one or the other. You really only need 2 points to draw a straight line. All right, so now we can find the x-intercept. Now, to find the x-intercept, is when y equals 0. And to find the y-intercept is when x equals 0. Kind of the opposite feel. So for the x-intercept, when y equals 0, I'm going to get 0 equals 5x minus 3. And I'm going to solve for x. So the point 3/5, comma 0 is the x-intercept. Now the y-intercept is when x equals 0, so y equals 5 times 0 minus 3. So we end up with the point 0, negative 3. So here are the x and y intercepts of this. And more often than not, if we want to graph this, if we already have the x and y intercepts, we can actually easily graph this. So I'm going to say this is negative 3, and this is 3/5. And there is our graph. Very nice, very easy to graph. We have another problem at the bottom of the page. So number 8 is actually on the next page, if you need to flip over. Find the point at which the line f of x equals negative 2x intersects with the line g of x equals 2x plus 8. That means that I'm going, well, if I want to find where two graphs intersect, I set them equal to one another. So negative 2x equals 2x plus 8. So the x coordinate is negative 2. I can plug the y coordinate into either one. So I plugged into the function f. So the point negative 2, positive 4 is where these two lines cross one another. In other words, if you have two lines and they're going to cross, we are looking for exactly that single point where the two cross. Now, you've learned in other classes, and we'll probably learn later in this semester, that when you have a system of equations, this is called, it's possible that they cross at one point. It's possible they don't cross at all, and it's possible that they are actually the same line rewritten to look a little bit different. Let's keep going. A rental company offers two plans for renting a car. Plan A, $30 a day and 16 cents per mile. So that's going to be $30 a day plus 16 cents per mile. Now we're going to let X equal the number of miles. The number of miles. $50 per day with free and limited. So this is going to be Y equals 50. So it doesn't matter how many miles in this case because it's unlimited. So if we set those equal to each other, we want to find that equilibrium point. So 30 plus 0.16x equals 50. This means x is 125 miles. That's the breaking point. So if we go one more mile, then plan A is going to be more expensive, and plan B will be less expensive. To save money, mileage must be greater than 124 miles a day for plan B to save you money. That's right. So if you know you're going to be going 126 miles or more, you want plan B. If you're going less than 125 miles, it's going to be cheaper to do plan A. And our last problem for this video. In supply and demand problems, Y is the number of items the supplier will produce or the public will buy, and the price of the item is X. And we have two of these, and we want to find the point of intersection, meaning we want to set the two equal to one another. I'm going to move the 3x over, and I'm going to do 544 minus 379. So it looks like we have a breaking point of 33. Now, X is the price of the item, so that's going to be $33. And that means that the product will cost So 444 is going to be 445, pardon me, is the number of items that are going to get us that optimal piece there. So that's going to be $33 per item will get us 445. And what is the selling price when supply and demand are in equilibrium? That's going to be $33. And the amount of items is the 445. And that is the end of section 3. Oops. And I want to thank you for listening to the video.